Hello, my name is Maria from mathmammoth.com. In this lesson, we're gonna solve some percent-related word problems. The price of an item is increased by 14%, and now it costs $55.86. What was the price before the increase? Like I've told you, in algebra word problems or others, we want to first write down what is our variable, so that the future reader will know what you mean. So, let some variable, let P be what it is asking for, price before the increase. Now I want to remind you of some simple principles relating to percent, and that is that we can use decimals. For example, if I have an item that's, let's say its price is 84, let's say it's discounted by 50%, then I could multiply the price by 0.5 to get the new price. If it is discounted by 20%, then I can multiply the price by 0.8 to get the new discounted price. If the price is increased by 10%, then again I can use a decimal number. I can multiply by 1.1 to get the new price after a price increase of 10%. This 1.1 comes from 10% being 0.1, and then we have an increase. We actually have the price plus 0.1 times the price. In other words, 84 is the price, and then we add to that 10% or 0.1 times the price. Okay, let's now get to solving the problem. But I still would like to encourage you to solve it first. Think about it first. So P is the price, and it's increased by 14%. That means that the price is multiplied by 1.14. And after the multiplication, the price becomes 55.86. Very simple equation. All we need to do is divide both sides by 1.14. And we get the price was $49 first. Next, what will you find out by solving the equation 0.94p equals $205? Think about it. Let's say P is the price of something at some point. It's multiplied by 0.94, and then it becomes this new price. So you will find out the original price after what was done. 0.94 means that the price got lowered. This multiplier here, or coefficient, is less than 1. This is actually a 6% discount. So you will find out the original price of some item after it had had a 6% discount applied, and the discounted price is $205. Now I want to remind you of another important principle in calculating with percents, and that is the percent of change. How did that work? It is actually based on the basic idea of percentages, which is that percentages are always fractions, and they are, in particular, they are fractions of the form part over total. And so we always write a fraction and then change it into a decimal into a percentage. In this case, when the number of unemployed people fell from one number to another, what was the percent of decrease? We look at the difference in this number of people versus the total that they used to be, versus the total number of people. So the part in this case is the difference. What was the actual decrease over the original total? The actual decrease is, to subtract these numbers, and the original total is this here. So it's the decrease over the total, and calculating. From a calculator we get 0.1039 and so on, which is, as a percentage, about 10.4%. Alright, just a little review of that concept. Next one, try to solve this on your own first. The price of an item was increased by 13% and then lowered by 20%. Now it costs $77.74. What was the original price? Again, let's choose a variable for our unknown. Let P be the original price. Once again, I'm going to use decimals. When I have my original price and the price of an item is increased, then it becomes 1.13 times what it was. So this is the price after the increase. Then this thing here gets lowered by 20%, which means I multiply it by 0.8 to get the new lowered price. 0.8 times this. And now it costs this 77.74. This is still a pretty simple equation. We multiply here these two numbers, or we don't actually have to. We could take the whole equation and divide both sides by 0.8. Then after that, divide both sides by 1.13. Maybe we'll do that. So then it is 1.13p equals this number divided by 0.8. Then after that, we divide by 1.13. And rounding it to the nearest cent, this is 86.00. So the original price was $86. Did you get the same? Next one, last one for this lesson. Let's say you're a merchant in a place where the sales tax is 14.3%. You're having a sale and you want customers to get a $100 item at $80 during the sale, so they would feel that, you know, things are nicely discounted. After the sales tax is added, so what should your sale discount percent be? It needs to be more than 20% because you want customers to get those items at $80 after the sales tax. All right, sale discount percent is what we don't know. I'm going to use R instead of P. You could use any letter. R as in rate. And I have this item. It's $100. I will multiply it by the sale discount percent. Or actually not by that. I mean, if the sale discount percent is, say, 25%, then I would multiply it by 0.75, right? So actually, if we are technical, if we're using R like we are using here, then I would multiply it by 1 minus R. You know, this is the discounted price, but then there's a sales tax added, so that means that the whole thing will get multiplied by 1.143. And then this would equal $80. The final price. At this point, I'm going to switch things just a little bit to make it simpler. Instead of using 1 minus r, I'm going to say that 1 minus r equals x. And I'm going to solve it for x. Then after I know x, I'm going to solve the r. It's going to be pretty easy at that point. All right, first we can simplify here. 100 times this decimal will be just a little bit over 100. So we will get 114.3 x equals 80, then divide by that, and we get x equals 0.6999, 1 and so on. Okay, so what would be our r? The sale discount percent then? This here is the number by which we would multiply, and 1 minus r being this, r equals, well, this is really close to 0.7, right? Using 30% as the discount percent should do the trick. Let's check that now. I will take my $100 item and multiply it by 0.7 to get the discounted price, 70, and then times 1.143. Yes, it gives me $80. So all is well, and we're all done with this lesson.